GCSE 91 Maths, okay, AQA Paper 3, exam style questions from the November 2021 actually, so looking at higher tier paper. And the later questions, yes, some of the questions here will also be from Paper 1 and Paper 2 as well, okay. This is question number 1, okay, B is 3 more than the square root of A. Circle the correct equation. So B is equal to 3 more than the square root of A. So it's going to be 3, okay, plus root A. Okay, it's root A plus 3. Okay, so think about it as root A, okay, plus 3. But the 3 here goes on outside of the square root here, so it's not actually part of it. Okay, which is going to be option number 1. Okay, because it's 3 more than the square root of A. Okay, that's 3 less than the square root of A, so it can't be that one. Okay, and these ones, obviously, yeah, it's put it on the square root actually, which is not actually what we want actually, so these two are going to be out. Question number 2, circle the largest number, so looking at our place value. Okay, so 0.5 actually with a dot means 0.5555555, so on and so forth, so it goes on forever. Okay, so looking at our values, well, if you look here, so that one's going to be 4 here, so that one I can ignore actually, that one has also got a 4 there, so I can ignore that. So it's between this one and this one, well, this is actually going to be a 0 here, so think about it as like a 0 and a 0, yeah, 0, 0, 0, 0 afterwards, okay, it doesn't actually change the decimal, okay, yeah, it's just so I can compare the place values. So look at the third place here. That's a 0, that's a 5. So that one has to be the biggest. Okay, so that one is the biggest. Okay. Question number 3, guys. A line has equation 3y equals 3x minus 2. Circle the coordinates of the intercept with the line with the y-axis. So it's in the form y is equal to mx plus c, where m is your gradient, okay, so how steep it is, and your c is your y-intercept, so where it crosses or where it intercepts or where it intersects the y-axis, okay. So dividing everything by 3 to get it in the form here, y equals mx plus 3. So I'm going to have y is equal to 3x over 3 minus 2 over 3. Okay. Now that just simplifies here just to x, because I can just divide top and bottom by 3. So I get y is equal to x minus 2 over 3, or minus 2/3. So it crosses at 0 minus 2/3. Okay, yeah, because c here is equal to minus 2/3. Okay, so the y coordinate is equal to minus 2/3. Okay, for that. Okay, when x is 0. Okay, for that. So that's the answer for question number 3. Okay, so make sure, yeah, that you are happy with, yeah, y equals mx plus c. So remember, m is your gradient, so how steep the line is, okay. If it's positive, yeah, or obviously greater than 0, then it's going to look like this in this format, okay, roughly like that. If it's negative, it's going to look like that, okay. And then, yeah, obviously if it's 0, then it's obviously going to be horizontal, okay, or vertical, okay. And then C is where it crosses on your y-axis, okay, or y-intercept, or y-intersect, okay, so where it intersects the y-axis, okay. Remember that your vertical, yeah, axis is what I call the y-axis, okay, yeah, so that's my y-axis, that's my x-axis, okay, so hopefully you're happy with that, okay. This is question number 4. Factorize x squared minus 64. Circle your answer. So this one, yeah, is what I call, yeah, the difference of two squares. So yeah, it's going to be like a double bracket. So it's going to be x and x, and then one's going to be plus, one's going to be minus, and then it's going to be the square root of 64. Now, the square root of 64 is going to be 8, so it's going to be x plus 8 times x minus 8, okay? Because if you expand that, okay, and you simplify it, the linear term, yeah, obviously, just obviously disappears here, because I get plus 8x minus 8x, or minus 8x plus 8x. When I expand the, yeah, using FOIL, okay, so yeah, there is no like, yeah, x to match here, so hence why, yeah, it's called, yeah, the difference of two squares, yeah, that's it. So I've got a square here, and then I've got a square number, okay, yeah, and difference means a subtraction, okay, or a minus. So it's option number 3, okay. So it's what I call, yeah, the difference of two squares, guys. Question number 17, okay, yeah, so jumping actually a bit here, okay, so m squared here is bigger than 9, circle the possible value of m. So this is what I call, yeah, a quadratic inequality, okay. So think about it. So yeah, let's just try this. So if I have like 1 squared is going to be 1. Okay, so yeah, that's obviously not good. Yeah, 2 squared, okay, equals 4. Okay, 4, yeah, is not obviously bigger than 9. Okay, so yeah, that was obviously not true. Okay, and neither is this. But when m is 3, I get 3 closer here. Okay, so we're getting closer and closer here. So that's not actually bigger than 9 because that's equal to 9. Okay, so we're looking for a number bigger than 3 or smaller than negative 3. Okay, because if you think about it, yeah, like minus 3 all squared is going to be positive 9. So we want a number, yeah, that is smaller than negative 3. Okay, and looking here, that will be this one. Okay, yeah, because that's equal to minus 3.5. Okay, as a mixed number. Okay, or minus 3.5. Okay. The rest of the numbers here are either less than 3, yeah, 3 or less, or greater than negative 3. Okay, yeah, so it can't be this much here because it's obviously yeah, it's bigger than minus 3. That's obviously yeah, smaller than 3, and that's obviously smaller than 3. Okay, for that one. Question number 25 is here. So expand and simplify here. So this triple bracket. So I'm going to do x times x, which is going to be x squared. Then I'm going to do x times positive 2, which is going to be positive 2x. Then I'm going to do minus 3 times x, which is going to be minus 3x. And then negative 3 times positive 2 is going to be negative 6, okay? So collecting my like terms here and simplifying this quadratic, okay, I'm going to have x squared minus 3x plus 2x goes to minus x. So that's going to become just minus x, okay? Put it here. Obviously, it's a bit of a gap there, but yeah, you got minus x, minus 6. Okay. So now, obviously, expand this here. So taking our time, x squared times x is going to be x cubed. X squared times 5 is going to be 5x squared. Minus x times x is going to be minus x squared here. So make sure you're happy with your negatives. Minus x times positive 5 is going to be minus 5x. Minus 6 times x is going to be minus 6x. And then minus 6 times positive 5 is going to be minus 30. Okay, simplifying this here by collecting your like terms. So let's just delete that. Yeah, now that I've got that bracket there, we'll make it a bit smaller. So you got x squared minus 6x, yeah, minus that. So just put this to the side. So I'm going to have x cubed. Then I've got 5x squared, subtract x squared here, so I'm going to have plus 4x squared here. Then I've got minus 5x minus 6x, that goes to minus 11x. And I've got the minus 30. That's the answer for question number 25. Okay, so expanding it and obviously collecting your like terms, so collecting your x squared together, and then collecting your x's together. Okay. Remember, yeah, so you are only able, yeah, to obviously collect, yeah, what we call like terms. So x's together, y's together, x squared together, yeah, x cubed together, yeah, x's together, and constants together, okay, yeah, so on and so forth. Question 20. A square has an area of 0.25 square meters. Okay, yeah, so the area of a square is 0.25, okay, meters squared. So circle in the length in centimeters of one of the sides. Well, the square root of this here, because obviously, yeah, it's actually, yeah, so square root of it, yeah, so think of it as I've got a quarter here as a fraction. That will equal to a half, okay, which same as saying 0.5. So each of the lengths in meters is 0.5, okay, and 0.5. Now meters to centimeters, I'm going to times it by 100, okay, so 0.5 multiplied by 100, okay, so it's going to be 5, then it's going to be 50, so your answer is going to be 50 centimeters, okay, so that's the answer for question number 20, okay, for that, okay. Question number 7, use approximations to estimate the answer to this sum. So approximations here to estimate, actually, so if you see the word estimate, think of rounding to one significant figure. So that's going to be the square root of 100. Okay, so 97 here goes to 100 to one significant figure. 2.014 cubed here is going to go to 2 cubed. And then 0.49 here is going to go to 0.5, okay? Right, so taking our time actually here. So the square root of 100 here, hopefully you're happy that's equal to 10, because 10 squared is 100, okay? 2 cubed is 2 times 2 times 2, which is going to be 8. So I'm going to have 10 plus 8, all divided by 0.5. Now that's going to give me 18 on the top. Okay, 10 plus 8 is equal to 18. Okay, divided by 0.5 here. So divided by 0.5 here actually doubles our answer, because if you think about it, yeah, 0.5 goes into 1 twice. So essentially, yeah, I'm actually doubling our answer here. So it's going to be 18 times 2. I'm doubling 18, which is equal to 36. Okay, yeah, so dividing by a half. Sorry, divided by 0.5 actually is the same as times by a half. Okay, yeah, a little trick there. So dividing by 0.5, yeah, in maths is the same as multiplying by 2. Okay, or doubling your answer for that, okay? Because if you think of it as 0.5 or 0.5 here into 1, go twice. So that means 0.5 here into 18, go 36 times. Yeah, because a half of 36 is 18, okay? And obviously a half as a decimal is 0.5, okay, yeah. For that, okay? Remember, yes, so essentially, yes, so remember, yeah, from obviously dividing fraction here, divided by a half is same as multiplying by 2 over 1, okay? Or by 2, okay? For that, okay? For that. Okay, question 21, guys, is here. So x is an integer. Prove that 35 plus 3x plus 1 squared is here minus 2x max squared minus 3 is square number. Okay, yeah, 4 more yes, yes, it's quite actually a nice question there. So yeah, it's expanding the bracket here and obviously simplifying it. So square number here, so it has to be in the form x squared at the end of this year, or something times here. Yeah, so either ax squared here or just something else. So it's in that form, okay, where a is just a constant. Okay, yeah, so a is obviously non-zero. Okay, so expand this. So I'm going to have 35 plus 3x plus 1 times 3x plus 1. And then I'm going to, yeah, just obviously expand that like last bracket to make it a bit easier for me. Then I'm going to have minus 2x times 4x here. So that'll be minus 8x squared. Okay, because minus 2 times 4 is going to be minus 8, and then x times x is going to be x squared, and then negative 2x times minus 3 goes to positive 6x, okay? Right, expanding this part now, okay, I'm going to have 35, okay, plus 3x times 3x is going to be 9x squared, 3x times 1, okay, is going to be 3x, 1 times 3x is going to be 3x, and then 1 times 1 is 1, okay? So simplifying this, guys, yeah, by collecting like terms here. So obviously collect like terms here and obviously simplify it, okay? What am I going to get? Well, I've got 9x squared minus 8x squared, so that's going to go to just 1x squared, or just x squared, okay? I've got 3x plus 3x, which is going to be 6x, plus another 6x, so that's going to be 9x. Okay, and then I've got 35 plus 1, which is going to be 36. Okay, for that. Okay. So this step now, okay, it's recognizing that I've got like a quadratic here. Okay, yeah, so it's in the form, okay, ax squared plus bx plus c. Okay, so what I call like a quadratic expression. Okay, for that. Okay, because I've got to think of it here. So think of the coefficients here. So 1 here is a square number, 9 here is a square number, and 36 is a square number here. So that means that if I'm doing a square number and a square number and a square number, yeah, I'm always going to get a square number, okay? But if I just try and actually factorize this here, if it is actually factorizable, okay? So on a sorry guys, yeah, sorry, it should be actually, yeah, it should be actually 12 there, not 9, I apologise. Right, there we go, yeah. Right, so now we're going to have x plus 6 times x plus 6, okay, which is the same as writing it as x plus 6 all squared, and that's squared at the top of the bracket means that I'm squaring everything, so that proves that it is in the form of a square number, yeah, because it's in the form of like a letter squared, okay. Doesn't matter what x is, that will always give you a square number. If x is 0, I'm going to get 6 squared. If x is 1, I'm going to get 7 squared. If x is 2, I'm going to get 8 squared here. So these are all square numbers, okay? Because obviously, yeah, 6 squared here is going to be 36. 36 is a square number. If x is 1, I'm going to get 7 squared here, which will obviously be 49 or 49. If x is 2, I'm going to have 8 squared here, which is going to be 64. Yeah, and so on and so forth. Yeah, for any value of x, okay? This one, okay, so x yeah, it can belong to, yeah, what we call like this set of like the real numbers, yeah, or real values. Okay, this is question number 13. Okay, so rearranging a formula. So rearrange y is equal to 1 over the square root of x plus 1 here to make x summation here. Okay, so the first step is I'm going to multiply both sides by the root x plus 1 here, so I don't have that on the denominator. Okay, so I'm going to times that both by root x plus 1. So now I'm going to have as follows here. So obviously be very careful and taking my time here. So I'm going to have y lots of root x plus 1, okay, is equal to 1. Divide both sides by the y, okay. So I'm going to get root x plus 1 is equal to 1 over y. The opposite of a square root is to square both sides. So I'm going to have x plus 1, okay, is equal to 1 over y here, all squared. So be very, very careful actually here. Okay, so I'm going to have x plus 1 is equal to 1 over y squared. Subtract the 1 on both sides, and then that will get me x is equal to 1 over y squared. Okay, subtract 1, okay, or I can write it as, yeah, as like a, yeah, like a one actually fraction, yeah, so write it as that, or I can write it as y is equal to yeah, 1 minus y, sorry, x equals 1 minus y squared, yeah, all over y squared. So yeah, that is like another one. Yeah. Okay, but yeah, obviously writing it as like a, yeah, like a fraction with like a common denominator. Okay, but either answer would obviously suffice in the exam, okay, for that. Okay, question 25, guys, here. So looking at some surds here, so simplifying surds. Show that the square root of 150 here minus the square root of 6 all over the square root of 2 times 3, sorry, all over the square root of 2 times the square root of 3 is simplifies to an integer, so integer just means a whole number. Okay, so what I'm going to do here actually, so the numerator, yeah, I'm actually going to simplify here, so root 150, yeah, it's a bit more trickish, yeah. So that's going to be root 25, okay, times something, okay. That'll be root 6, yeah, because obviously, yeah, 25 yeah, times 5 yeah, will be 125 actually, yeah. So yeah, if you simplify that, okay, root 25 yeah, it's going to be 5. Okay, so I'm going to have 5 times root 6, which is going to be 5 root 6. Okay, so the fraction now becomes, okay, on the top, 5 root 6, subtract root 6 or minus root 6, and then root 2 times root 3, yeah, it's same as saying root 6. Because I can just write it in here as that one, yeah, part. Okay, so that will obviously give me a root 6 on there. Okay, so I'm going to get on the top, I'm going to get 4 root 6. Okay, because think of it as I've got one lot of root 6 there divided by root 6. The root 6's just cancel, so I just get left with just 4 over 1, which is just 4. Okay, or 4 and then 1 there and then 1 there, yeah, or 4 times 1 over 1, which just gives you the answer of 4. Okay, 4 over 1, which is just 4, guys. So that's the answer for question 25, guys. Okay, yeah, so make sure that you're happy with that simplifying surds. Yeah, and obviously, yeah, multiplying surds, yeah, as well as, yeah, and obviously simplifying and collecting your like terms here with surds, okay. Okay, guys, so completing this square, okay, yeah. So the equation of a curve here is y is equal to x squared plus 14x here plus 52. By completing this square, work out the coordinates of the turning point. Okay, you must show your workings. Okay, so completing the square here. So the method is as follows. So I do, in brackets, I do, yeah, x plus half of the coefficient here of the x, so half of 14 here will be 7. So x plus 7 here all squared. Take away, obviously, yeah, the square root here, so it's going to be that. So take away 7 squared plus 52. So that's going to give me y is equal to x plus 7 all squared, subtract 49, add 52. So y is equal to x plus 7 all squared. Okay, and then I'm going to have plus 3. Okay, so that's going to give me plus 3. Okay, when you simplify that, okay, because that's the same as saying 52 take away 49. Okay, so minus 49 plus 52 here simplifies to the number 3. Okay, so that means that my coordinates here are as follows here. So it's going to be minus 7 for the x coordinate, and the y coordinate here is going to be positive 3, or just 3. So your answer is negative 7 and 3. Minus 7, 3 is my coordinates of the turning point. Okay, yeah, so the turning point just means, yeah, like the minimum point, okay? So the point here at which obviously the graph here is at its like lowest point, okay, yeah, in this case, okay? For that one, okay? Question number 30, guys, yeah, so looking at, yeah, some like iterative formula here, okay? Yeah, and this one, yeah, it is a paper 3 actually, and this one actually, and this one actually, yeah. Okay, for that one. But what I'll do here is I'll do 15 first actually, and then I'll come back to you, yeah, to question 30 actually. Sorry if actually we got a lot actually, I apologise. Guys, yeah, hopefully you can forgive me. So yeah, here, okay, so yeah, I'm going to be obviously expanding back here and obviously collecting like terms. So I'm going to have x squared plus 3ax plus ax plus 3x squared, sorry, 3a squared. That's going to be equivalent, yeah, i.e. the same as here. So the 3 lines here means that, yeah, left hand side here is the same as the right hand side. X squared plus bx plus c. Sorry, plus 75, sorry, not plus c. Okay, now comparing your coefficients, okay, so s squared here is equal to s squared, so that's obviously fine. Okay, the constant, okay, or yeah, the coefficient of x here actually. So I'm going to have 4a, okay, is equal to b. If you compare the coefficients, okay, of the x's, okay, yeah, so compare coefficients of the x's on both sides of my identity. Okay. So the 4's come from 3a plus 1a, okay. Sorry guys, my handwriting is pretty actually dreadful, actually, I apologise. Okay, of x's. And then if you compare the coefficients of the constant terms, I'm going to have 3a squared is equal to 75. So 3a squared is equal to 75 here. So I've got like an equation here. So divide both sides by 3, first of all. Okay, so I'm going to get a squared is equal to 25. Okay, and then a, so the opposite of squared here will obviously be a square root here, but I'm going to be careful here. So a is equal to plus or minus the square root of 25 actually, yeah, okay, which gives you plus and minus 5, okay, because this is what I call, yeah, like a quadratic, and a quadratic, okay, yeah, if it's like a letter squared, that is what I call a quadratic equation here. So that will have two distinct solutions, okay. And then obviously, yeah, I'm going to sum that actually back into here. So I'm going to have 4 lots of, yeah, plus and minus 5. So I'm going to have plus or minus 20. Okay, because 4 times 5 here is going to be 20. You're going to have plus 20 or minus 20, okay? And that's my answer for question number 15, okay? So hopefully, yeah, that actually makes sense there, okay? So this is looking at, yeah, so yeah, it's looking at, yeah, comparing identities, yeah, identities actually. So an identity here means that all the values on the left hand side here is the same, i.e. equal to here, i.e. true for all the values on the right hand side here of my identity. Okay, so in this case here, so the values for x here, so is true. Okay, yeah, it is true here for all values of x on the left hand side here as it is for the right hand side. Okay, for that. Okay, so yeah, that is what the three actually lines there actually. Okay. On there. It's treated similarly. Yeah, it's treated similar when obviously if you're obviously comparing coefficients, yeah, then obviously you're obviously going to form some equations there. Okay, so comparing coefficients, yeah, so looking at the coefficient of x's, coefficient of the x squared, and then coefficient of the constants. Okay, and then form some equations. Yes, equations here from there. Okay. Question number 30. It says sphere has radius actually r. So it means an approximation value can be found actually using this iterative formula. Okay, the starting value is going to be R1 is 7, so work out the value of R1, R2, and R3. See, yeah, obviously R2 is when n is equal to 1. 7, okay. And then, yeah, and obviously, you obviously enter that in your calculator and obviously get a value. Okay. For R2, okay, I'll try to work it out here quickly on my calculator here. So 239 divided by 7. Okay, I'm going to get 34.142857142857114. So square root that. And I get 5.8. Yeah, so obviously a bit of actually around here. So 5.843188953. 2, okay, yeah, so that should be like enough there, okay, for that. Okay, so R3 will be the square root, yeah, obviously that number, yeah, divided by that number, so it's going to be 239, okay, divided by answer, okay. Okay. So write that assume, so I'll write it down here. So 5.843188955. Okay, so I'm going to have 239 divided by 5.843188955. Press equals, and I'm going to get 0.9023227. Okay, and again, you might have like a different like level of accuracy here. So R3 here will be equal to 6.395493. Okay, yeah, I'll leave it as that. And the first one here will be 5.84318895532. Okay. So that, okay. I'm going to put a 7 here, yeah, you've got 7 there. Okay, so continue this situation here to work out the radius here to one decimal place. Okay, so yeah, so it is going to obviously, yeah, like reach like a particular value, okay. So, yeah, I'll write them down here. So I'm doing this on my calculator here. Divided by 6.39549237 and square root. You're going to get 6.11. Okay, so I'm guessing the answer here is going to be around, yeah, 6.1. Okay, yeah, it is my rough guess. Okay, roughly. Okay, so that is my guess here. If you work it out, yeah, several steps later. Okay, right, guys, that's the end of today's video. Actually, hopefully you found it useful. Actually, sorry if actually stuttering, like stammering a lot actually in the video. Hopefully it made sense. Any questions, any queries, put it in the comment section. Thank you so much for watching. If you did find it useful, please like, please comment, please share, and please subscribe, and click that bell icon so you can be notified of my uploads. I'll see you inside the next video. Okay, bye for now. Take care. All the best, guys. Okay, take care. All the best. Bye bye now. See you later.